All right. Hello, everyone. Welcome to our YouTube live session. We'll get started in about a minute. We'll just let some more people join in, and then we'll get going. All right. All right. Why don't we get started? Thanks, everyone, for joining. We'll do some quick introductions before we get started. My name is Charlie Ogden. I'm a product manager at Autodesk, mainly focused on grading and drainage features in our infrastructure products, Civil 3D and InfraWorks. Val?
I'm Val Koch, research engineer here at Autodesk, focused mainly on optimization, grading optimization, road corridor optimization, whatever you can optimize. Your mic is on mute, John.
Yes, I'm learning to unmute, right? So, my name's John Sayer. I'm a technical marketing manager here at Autodesk. You probably see me on several of the videos that are on YouTube, our YouTube channel, and any of the new features like Civil 3D new features, webinars, things of that nature. So I will be answering questions this morning. So if you have any questions, put them in the chat and I'll do my best to get them answered. So take it away, Charlie.
All right. So, and you also may see that this is session 5 or part 5 of 6 of these grading optimization YouTube live sessions. We put these together to hopefully give some information on how to best work and workflows to use with using grading optimization for Civil 3D. So under the video in the description, you can find links to the previous webcasts or sessions and also the next upcoming one. So set a reminder for that one and hope you join us there. Let's see. So yeah, John said he'll answer questions. So if you have any questions, just throw that in the chat. And if there's anything still at the end, we can have a little Q&A session at the end afterwards. So with that, why don't we get into it? I'll start sharing. So today we were going to talk about subdivisions, grading a subdivision, and we want to grade this to balance the whole area. And we're going to show you a bit of a workflow that that we want to do really to grade and balance the entire subdivision, but also to have nice roads from corridors. So the grading optimization, as you know from the previous sessions, it's grading the triangles, and it's really not for like built for a road really, where it's not creating road profiles. The smoothing will smooth out the transition from adjacent triangles to kind of create that similar thing that a vertical curve does, but it's not going to be real vertical curve geometry. It'll kind of get you close. And also, it's not doing perfect cross slope along the road. We'll put in a min and a max, but the cross slope can vary a little. So to work around that, I guess, what we're going to do is after we balance the whole thing and get an optimized surface with kind of really focused on the roadways at first, and the slopes and requirements kind of in the road area, we're gonna take that optimized surface, go back to Civil 3D, create profiles along there that would then be built into corridors, and then we can take the corridor surfaces, paste it into our optimized surface, bring that back, and we'll show how to not grade within this corridor area, and then work on grading the whole rest of the site. So the roads from the corridors will stay fixed, and we'll grade the rest to get a balanced project. So again, we'll start here with just kind of grading around the roads, go back to Civil 3D and come back a second time. So as with any of the grading projects, we always start with a grading limit. So I'm gonna start by setting the grading limit here. And I'm gonna
Put that to 0. The reason is because we want, if you put that to 2 like it was, there will be like inclinations towards closed drain elements or whatever, but we want it to be free to go and shape wherever it wants, the triangles, if they don't have to drain to a specific place. So.
And I should mention the shape of my grading limit here. So what I did was, I just went 5 feet off the back of the property line in cyan color. And then along the front, I went right up to the right of way. But where we have the roads coming in, we need grading limit should be everywhere that we want to allow grading. And, we need the roads to come right up to the existing pavement. So I did bump these out at the roads so that, grading can happen and actually tie into the edge of pavement here, and then grade in the roadway. And also in some cases, maybe take some caution. I have curbs here. Curbs are going to be offset back about half a foot, which I think is roughly where this gray line is. So I also want the whole curb, even though my line work is the front. I wanted the offset to the back of the curb to also be within my grading limit. Otherwise, your curves might get ignored. So if you notice that happening, first check and make sure they're inside your grading limit. All right. So next, I can set the zones for the pavement areas. Oh, sorry. Well, it doesn't matter. I'll do the right of ways first. Yeah, I'll do the right of way. So, so I have right of way areas here. I'll just select similar because I have one for each road. And I'm just going to add those as zones. And inside the right of way, I'm going to have a pavement area too. So this is really the grass. So I'm going to leave it 2%. I'm just going to say 2 to 4%.
The 2% min is because this time we want some sloping towards the road, the right of way. So we're going to show how to do that in a bit.
And then the pavement too, I can select 3 pavement areas and create those as zones. And for these, I'm going to go 1 to 6. And then just to better define the roadways, I'm going to turn on some geometry for curbs. So you can see kind of already connected all these polylines to have curb lines. And I'll just select similar so I get all the curbs. Add these as curbs here.
Make sure that the top is on the correct side for curbs. You can see there the higher side of the curb displays as a shaded line. So in this case, it looks all right.
Yep. And the
right?
darker is the face of the curb. shaded's the top side of the curb, and it
Now,
looks like they're all right.
yeah, they are. I think they look like right. And now the curbs, they also have a different functionality in this case than just making it look nice. It's curbs are mainly under the hood. They're just offset points that we go along the road, and you create a little zone that is your curb wall with infinite max load. Then there are offset points from the top of the curb down to the bottom of the curb. And these offset points, they happen at quite a few intervals, like small intervals. And you will see this will create a triangulation that is nice for crowning for our road. You will see that right away when you add the drain lines.
Yeah, it's actually starting at the lower face of the curb is going to offset slightly to the top face of the curb, and then again the curb width to the back, right? So so also to get that shape Val's talking about, we want to actually add some drain lines in here. So again, I already have them drawn, so I'm just going to turn on drain lines.
The important thing with the drain lines is, you know, in one of the first webcasts, I think we talked about how triangles incline themselves towards drain lines. And if they're away from a drain line, they go perpendicular. If they're touching a drain line, they go towards the tip of the drain line. Now, this is really important in this example. We don't want on the pavement, these triangles, we don't want them to be inclined towards the tip, because then the whole road is going to become like a channel that goes down towards the end of the drain line. So what we want is really that these triangles go perpendicular. So that means we need to make sure that they don't really touch this drain line. And the trick how Charlie and I are doing this is we're offsetting the pavement there, the geometry a little bit, and by, what is it, 0 point?
It's, yeah, 0.005. I picked that because it's half of the actual vertical face of the curb. That offset is 0.01, so I just picked halfway just so it's somewhere in between that vertical face, somewhere right in the middle.
Which is good because there we have no constraints. It's a wall and the drain line is right there, and the pavement doesn't touch the drain line. So these, we should get nice crowning that way.
So I'll select all of these. So I have them all around now. And here I'll just add them as drain lines. Now I also, on this layer, when I created these, you see these blue circles. I was just trying to first lay out where I wanted all the drain lines to flow towards. So the slope. So, you know, it's higher in the bottom left here. It's much lower down in here. So I wanted all these to flow this way, basically flow towards all these blue circles. So you want to draw your drain lines in that direction, and you can always reverse them after the fact. So just quickly, I'm going to just, so we can see these, turn off the curbs and I think the road edge, just so you can see the drain lines. So if you're not sure if you drew them in the right direction, or maybe you were p-editing and joining a bunch, and then, you know, they could be in the opposite direction you thought, you can always go in and use the edit geometry tool, reverse, that you might use for feature lines. And if you come in here and select one of those drain lines, you'll see a little arrow showing the direction. Now it's actually reversed it on the first pick, so they're now all going the wrong way because they were actually right originally. But if I just pick it again, I'll see now they flow down towards that. Same with here, I could just check and that one was right, so I'll just pick it again. I think all mine are already right, but you know, worst case, you're just picking them twice. So just one way to check that you know, these are flowing the right way. Hopefully that's big enough you can see a little green arrow, but
I can.
All right, so now we have drain lines, and so that should kind of define the crown towards the curbs, and also the right of way towards the road, because those will want to slope towards the drain lines. And then,
And the terrain will also flow to these circles that you said, like outside, like the right of way will go a little bit.
yeah, towards
That one
those.
might, yeah.
And then we probably want the lots too, at least the fronts, to flow towards the road. So what I did here too, and also we want them flattened out. We want, you know, where we're gonna put buildings, just kind of flatten out. We can tweak this a little bit after we have our roads done, but for now, we're just gonna add some it's kind of a smaller slope in this area. So I'm just gonna select, I have kind of a yard zone around each roadway. And I'm just gonna add these as zones just to kind of, like I said, flatten them out. So I'm just gonna go 2 and 5. So again, you know, otherwise this whole area is just the grading limit with a 0 minimum drain. So I want to at least give it a 2% minimum drain, so it starts to flow towards those drain lines.
Make sure that these zones are inside the grading limit again. Otherwise, if they're just a little outside, they might get ignored. And the other thing
So I
is,
tweaked this one, you can see, just to pull it in inside the grading limit.
right. The other thing is, make sure that these yard zones don't cover everything. You can see there is like this little free area between the two, the left and the right side, and between these lots too. And that's actually good because I think we mentioned that in the beginning as well. You always want to give this solver some freedom to move things around, like when you want to balance that it can put some dirt somewhere or get somewhere else. And so 5% is quite flat. So leave him some room in between and it will just work better.
And one last thing I'm going to do, just because I don't necessarily need all of these yards to flow towards the road, like the back could flow towards the back. So what I have also, I'll just turn on another layer here, just some other drain lines in the rear. I'm just gonna select each of these, just that'll get, you know, some of these yards to flow backwards instead of the whole thing flowing towards the road. So you could set those up depending on, you know, kind of how you want them to grade. So here, let me just add these first drain lines. So what it'll actually do if I select the road ones too. So midway between all the drain lines, it's going to choose, you know, the closer drain line to go to. So this will end up getting the backs of the lots to go to the back and the fronts to go towards the road. And you could adjust kind of where those are to control where it splits. But yeah, I think we're all set up here.
Start grading optimization.
And then once this opens, the first thing, like we said, probably in the first webcast, we want to make sure we order the zones. So, you know, whenever you first set something up, always go in and check the zones. Because what you want,
Top ones override lower ones. So if one is, for example, here, the pavement, we don't want it to be overlapped by anything else, so we put it on top of the right of way because the right of way is actually bigger than the pavement. So pavement on top, then right of way, and then the yard zones. Is that right there?
yeah. And these are, no, it's not right now. So these are my road pavement, the road edge, so my pavement. So I'm going to drag these up, like Val said.
They're the smallest one, and we want them to float on top.
And that was the only reason why I created the right of way first, just so they were out of order, so that I could move them up. But now they're in the right order. I think generally the first ones you create are usually at the top. the last ones are usually at the bottom. So we have now our road edge on top, or pavement, and then the right of way, and then the yard zones. And they're all then covering the grading limit. So grading limit's always on the bottom. All right, so we can just start.
No, first we want to set our objective. What do we want to optimize, right? Default is smoothing surface, but we want to balance here. Now, remember last time when we did the mass grading one, we mentioned that there was a defect that we found. This defect is still in this version. We identified the cause. We're working hard to get a fix out. We showed a workaround how to work around this, and we will see that here as well in a bit. So it is the target volume. We don't set it right now. We just, but we don't start yet, Charlie, because there is one more thing I want to show them. In this problem, we have a lot of round geometry, and when it refines the surface, or when it retriangulates the surface, it tessellates around these rounds and it creates a lot of triangles. Right now, it's not so bad, but if you would just start optimize right now, it creates a large number of triangles, which is not a bad thing. It's just going to take longer to optimize. And because we don't have the time here, we just make it quicker, and we go in the settings on the left side there. Yeah.
Preferences here, yeah.
Yes, and we just, there's the, by default, refine surface is on. We just turn that off, which means it will triangulate not as nice, but it will also create less triangles. And it's going to be, ultimately, it's going to be faster. That's just also a trick if you work with a huge surface and you think it's too slow, turn that refine off.
Yeah, at least to make sure everything's set up right and kind of running like it's going to work, and then turn it back on and you can let it run on its own. With it on, just to point out like what it would try to do, you see all these long skinny triangles, it would try to break those up so they're a little more even shaped. Otherwise you get long slopes and can create some odd contours and grading. So some of that might be a little odd, put this off, but yeah, what we would do and what I did do is actually turn it on and let it run on its own later. But we'll leave it off for now, and we'll optimize.
And now you can see it changed the triangulation a little bit.
And
we can turn back to contours maybe to show what's going on. Oh yeah, one thing you can see now is really in the triangles. I can show the triangles again, Charlie.
Yep.
You could see these elevations, offsets, the offset points that I mentioned on the road, how they create this triangulation. So that's nice for getting our crown built. So you can go back to the contours and they will see the crown shaping there.
And you can see it's trying to at least get the minimum slope towards the edge of the road. That's what the direction vectors here will show us. Contours, turn those off.
Now, the defect we mentioned, if we look at the volumes there, we can see it's not going to zero. It's hovering around, what did we find out, Charlie? It's 100.
I think it was like around 140.
140.
Negative 140.
Negative 140. So what you
fluctuating
would,
between 120 and 160-ish. So
yeah.
around 140.
So if you let this run longer, it would settle closer to a certain volume there, which is the defect we have. So what you would do for a workaround right now in this version is that you would, after a while, stop, then take, because this is a negative 140, you enter this in your target here as a positive, and then just run it again or keep running. and it will
Yeah.
bring it now to 0, basically.
If I start again, I haven't turned anything on or off or changed anything to change triangulation. So it should just kind of pick up where it left off but adjust itself to meet the new objective.
Again, we're working on a fix, so that's just a workaround.
So now these numbers are 10 times smaller, and the longer like I said, I did run it longer on its own, and they do get within like a couple hundred or so. All right.
So once we have a nice balanced surface, with the roads in, we can actually then stop and send the surface back.
So in this case, yeah, I mean, we would let this run longer. I might even turn on the refining and let it run on its own and then send it back. But yeah, for purposes of not taking too long here, just going to stop it here, send this back. And I'm just going to turn the feature lines off. I'm just going to send the surface back. And I'm just going to call this geo. Nope, just put 2 and 10 design contours and let that go. And so this will create that surface that, you know, it's still a bit rough, but we can use this to generate some profiles for our roads. So instead of having you watch me create corridors, I'm just going to open up a drawing where we did this already. Right, so we have, you know, kind of the geo surface in here, and let me close this so you can see the profiles. So created some profile views with the red is the existing ground profile, the black is the optimized geo profile. And what I did was draw in some proposed layout profiles just to closely follow the optimized one, but to put in real vertical curve geometry. You can see it, you know, the optimized one smooths it out a bit. It's not just a straight, you know, change in direction, but it's not smooth enough for a vertical curve. So tweak those a bit so that, you know, we have good geometry here, but you can see there's an elevation difference between our corridor profile and our geo optimized surface.
And now, of course, if you create these corridors like that, the volume will change a little bit from what you got back from grading optimization. And here comes the trick from this workflow, actually, which is the one thing you should take out of this webcast is what we're going to do is we create a volume report now between the surface geo and the corridors. So this surface that we just created was adding these corridors and EG. And when we create this volume report, what you're going to do then is you're going to...
Yeah, I should point out too. So after I created the corridors, of course, I created surfaces from those, and then I pasted them into a copy of the geo. So I have a composite of the return geo surface with the corridors in it. So that's the one I'm comparing here.
Right.
And this is just corridor difference.
And even with our defect from before, if it wasn't perfectly balanced, we will now see a net volume here. There we go, of 2,612.7 cubic yard, and that's a fill. That's the difference to our EG. And what we're going to do now is we convert that to cubic feet which is about 70,542 cubic feet. And we note that down somewhere because we're going to use this. This is the trick that we're going to show. We're going to use this as a new target volume. But before we go back to Geo, we're going to actually, we don't want Geo to destroy these nice corridors, right, Charlie? So,
Right. So remember we had the right of way zones where we put in a min and a max, but everything inside that right of way now, we just want to use the corridor grading. So what I'm going to do is change those to exclusion zones right here. So I'm going to take the 3 right of way lines. I'm going to right click and remove the grading, the zone properties on it. And actually don't really need to do that step. You could just pick exclusion zone, which would then remove the original one and put exclusion zone on it, but I'll just do it as 2 steps. So now they're still selected. So I picked the exclusion tool. So it's now turned those 3 into exclusion zones. So now it'll exclude everything inside the right of way. So even our road edge pavement zones, those won't be used either. Just the right of ways will be fixed and it'll grade outside the right of ways.
we can add some building pads now.
Yeah, so we can flatten these areas where our buildings. Now these I just created roughly from like the front yard and side yard setbacks. I just created a big rectangle, kind of offset back, I think 30 feet or maybe more. But anyway, I'll select all these, and they're not building shapes. I just kind of created some rough shapes just to flatten out part of the lot where the house might go. You could, of course, be a little more careful about how you're creating these, place them a little bit better. So I'm going to turn all these into building pads and make sure level grading with pad is on. Then I'll kind of try to keep the ground around the pad flush with this proposed surface. I'm also, just for the purposes of this video, I'm setting depth of material to 0. You could certainly give it the depth of the material and that'll get accounted in the volume calculations. But then if you want to compare it in Civil 3D, you want to make sure you also create a datum below. Otherwise, they're not going to compare easily. So for the purpose of the video, so we can show volumes later, I'm just going to leave it at 0. So we're just comparing top to top, but you don't have to work with just top to top.
And one more thing is now in our yard zones, before we had them at 5% max. But if you look at these building pads, they're very close together. So, and the building pad, it tries to make it flat. So what it's going to do here with the sloping of the terrain, it's going to create something like a staircase. And since they're very close together, you want to give the solver a little bit of room in between to build this stair. And with 5%, it's probably, we tried it, and then it's not going to be able to put your building pads really flat. So what we're going to do is we're going to increase this a little bit, and we give it 15%. There was one that did a different value.
That's a new zone I put in here.
Okay.
I'll change that one after. So I just said the 3 yard zones plus this new one I'll talk about all to 15%.
And then I think.
And then so why I created this other one was just to also, first time we didn't have this, but just to better define the area kind of outside the yards, because we do have the drain lines I created out here. But I just wanted to create a zone out here that's allows 3 to 1, but also, that's what the grading limit is, 3 to 1. But but also kind of just let it all flow towards these drain lines a little bit nicer. I'm putting in a 2% here. Otherwise, it would just be the 0 from the grading limit, but this will just kind of help define it a little bit better inside, in between all these yard zones.
Did we talk about the drain lines in the backyards? I think we didn't, right? These red ones.
Yeah,
we
no, I
had-
did. I talked about these.
You talked about
We
these?
had-
Okay.
These in the road, and then that's what gets it to kind of break.
The crowning. Okay. Yeah.
So the back
Yeah.
of the lots go towards those, the front goes
Yeah.
towards the road. And then what, the last thing, we'll just add ponds, right?
Ponds, yeah. John knows how to do that, right, John?
And
Still struggling with that unmute button. Sorry about that. Yes, I am very familiar with ponds for sure.
Oh, I thought you were still struggling with the ponds. So.
Well, that could be the case also.
so actually, I'm just gonna leave these kind of basic dry ponds with the maximum depth and put in a volume. Now, I don't know actually how big these are, and I just kind of want them to be this size, whatever they are. So I'm just gonna put in a large volume and don't allow boundary change. So it should actually tell me what the volume it can do in here. If it can't meet this large volume. So I'm just gonna roughly set it at that. And I think we're all set to run it again, right?
Yeah, I think that's it.
So we'll optimize again. Now this time we want to optimize using our geo plus corridor surface, not the existing ground this time. So we want to start with the surface that had, our returned geo optimized surface with the corridors pasted into it. So that's the one I'm picking here. Geo plus corridors.
Now, the first thing you want to do is you still wrote down that volume difference between the EG and your corridor surface, and that was what was it? 70,543 cubic feet. And we're gonna enter this. So it was a fill. Is that right?
Yeah, it was a fill. So we want a cut value.
We want a cut value. So we want a positive one in here because this is cut minus fill, right?
Yep. So what was the number again? 70?
7543. Perfect.
So that'll adjust for the slight difference with the corridor. Slight difference between, I should say, the corridor and the original optimized surface. Just move that to the side. Right.
Now we can actually run it.
Now I could also,
Oh yeah, you can turn these
I could
off.
turn the curbs off because they're inside the right of way. They're not even really going to be used. Probably don't even need to turn them off, but I don't know if it takes some thought out of it. So, and also I did create a new zone for this round. So I just want to make sure that one is at the bottom because I want it underneath all the yards. So only the areas that don't have yard zones will use this bottom zone, and the exclusion zones should probably just hit optimize at the start. But yeah, the exclusion zones are listed here as well.
Now about exclusion zones, it's going to start soon. So we see it's still preparing, retriangulating. What is actually an exclusion zone? It's a zone where under the hood, again, what we do is we relax all the constraints. So there's no max slopes on the triangles. There's no min slope or whatever. So this is an area the solver is not going to touch because there is no constraint on it, except on the boundary. The boundary we put bounded points. Did we ever cover bounded points? I think we did in the beginning. Did we?
I think in the first one or the second one, I don't know.
Anyway, bounded point is a point where you can define within a certain elevation range, the point should stay. And here is the exclusion zones. What we do is this is not a range. It's basically a fixed elevation that we enter. And so every point on the boundary of the exclusion zone should stay at that elevation. Now, this is just another constraint, like any other constraints in the model. And so if sometimes they might be fighting with other constraints nearby. So it could be that you see this boundary of exclusion zone move a little bit, and the solver then puts it in place again. So just keep in mind, this is because these bounded points are just constraints like any other, and the solver works on them.
Yeah, so if you let it run longer, these should kind of work themselves out, come as long as they can, come back to, you know, what you had in the corridor.
Now there's some notifications there, Charlie.
Oh, yeah.
You want to
So,
show
yeah.
us?
So I mentioned, like, I just kind of roughly put in a large number for the pond volumes, just because what I drew is what I wanted. But here, so it couldn't meet that volume, but what it's doing is telling me the volume it can meet in there. So it's given me for each of the ponds what the volume it could get. So I can see 22, 40, 87, all in cubic feet here. So it's kind of nice to get that data back. Yeah.
Now, if you go on the volume tab again there, so keep in mind that when this runs now, that your net volume here should not be 0 anymore. So what you're looking at is what you entered as a target volume, which was our positive 70.
I
That
think
right?
I closed it. I meant to leave that open, but yeah.
Good. It's okay.
It was positive 70 something.
It was
So
70, 500, yeah. So don't, if this volume is positive 70 or whatever you entered, yeah, don't mix it up with, oh, it should be 0. No, it should not be 0. We want now our target volume.
still fluctuating a bit, but
Would be 70,540. So if it's around there, we could even stop then.
yeah, anything else to talk about? Should I
No,
just stop it here?
stop it there.
72 is close.
It's close. Yeah.
If we let it run longer, of course, it would get closer to that target. So I'll send this back.
So now 72. So we're about 2,000 cubic feet. That's,
And again, what I would probably, we still had refining off, you know, I'd probably, if was really what I wanted to kind of finish up with it, I would turn refining back on and just let it run. It would take a little longer. But again, for the purpose of this, I'm just gonna call this our final.
so now because we stopped early, we're about, yeah, about 74 cubic yards off our target.
So finish up with this, we could probably just do a quick volume check when this surface gets created. Questions, John?
I didn't hear you. It's answering like crazy.
By the way, guys, while we're waiting here, we do have a couple of good questions. So I want to be sure we have time for the Q&A.
Yeah, go ahead.
Oh, you want me to hit you with one now?
Sure.
Yeah.
Well, this is just finishing up triangulating this.
Okay. And just so the folks know that are giving me the questions in the chat, great questions today. If I didn't answer the question and said we would ask it in Q&A, it's because I needed to leave questions for Charlie and Val. So
Thanks.
I wanted to make sure that that they had something to do. You know what I mean?
That's nice, John.
Always looking out for you, right? So there was a question. Can the solver determine if the lots should be FHA type A, type B, garden or walkout lots during the overlot grading? So when you're doing the grading for the lots, can you determine that? Or can the solver determine any of those different types of grading?
Yeah, the solver's probably not, but you'll probably see maybe a lot of red in the violations where it can't grade. So maybe you want to put in a walkout just to have a elevation difference set between the front and the back. I think that's probably just based on violation, something you might want to make changes.
Walkouts you can get built automatically if you turn that the thing that Charlie did, level grading with pad or level pad with grading. Can't remember which one comes first. If you unclick that one, it basically creates reveals around your building pad. And if, for example, if you have maximum slope constraint somewhere, it will just create you this walkout automatically.
Well, but it won't be, you'll want to actually go in and define the reveal so that you have the right elevation difference.
Yeah.
So yeah, you can use the reveal feature we showed in earlier, probably the second webcast, to get the actual elevation difference you want.
So can we quickly do the volume report for EG and our final?
Yeah, so you want G.
And if I'm right, I expect something like 74 yards or 70 something yards because we finished early. If I'm wrong, then we have to explain it somehow.
What did you say that?
I think it's about 74 yards. 35. Okay. Oh, we were closer than I thought then. I thought it was like a 2000. Well, it was very rough. Yes, 2000 cubic feet. We were off when you stopped. But it was probably a bit less. So yeah, 35. 35 is not bad.
Yeah. Yeah. Okay.
If you would let this run longer to your target volume, this would probably become 0, this net, or close to 0.
Yep.
I mean, it's not bad. How big is this subdivision, Charlie? Surface wide, is it?
Yeah.
Wide.
2.16 million square feet. But anyway, I guess that's basically the workflow we wanted to show. So kind of using an initial geo-optimized surface that balances the whole site to use that for our corridors. Instead of, maybe what you do today is just kind of balancing just the roads, just based on the profiles, but and then rerunning it so that we can grade it a little nicer with the roads included.
I believe it's about 60 acres. Is that about, does that sound reasonable?
So, Sean, any other questions?
Yes, I've got another question. I've got to find it here. I've been answering other questions. Again, thanks, guys. Great questions. Clayton, yes. Best fit profiles work good. That would be a bet, guys. So just so you know, Val and Charlie, there was a question about the workflow again, how you molded the corridor, or how we molded the corridor surface in with the overall grading. And you would, like Charlie showed, you would initially grade the whole site for if you were trying to balance, grade the entire site the way that Charlie showed today, and then for more finite grading, you can go back in and add a corridor and all those roads like he just showed, and you can tell it in the corridor to follow that surface that you brought back from the optimizer. Okay. You can either tell it to do that. I've done it two different ways. I've actually told it to follow the surface it returned. And then I've actually gone in and drawn a finished grade profile over the top of the surface itself in the profile view. And then like Clayton, asked, I've used a best fit profile. The only thing with the best fit profile is sometimes you're still trying to meet minimum and maximum K values in the roads, because everybody knows, like for this particular project, I think it's 25 miles an hour is the speed. So there's minimum and max K values for crest and sag. So that would be the real reason why you would even add a profile in, because you're not inputting that into grading optimization, that particular information. So when I say it creates more finite grading, that's what I'm talking about. You're meeting the codes that you're being given for the streets. But the great thing about it is that you're assured the fact that the site balances, period. So when you go back in and add the corridors, it's going to be minimal how much that earthwork changes. And you guys correct me if I'm wrong, right? But I mean, we've done this 100 times, and it's been minimal how much that earthwork actually changes whenever you follow that grade. So now after I've gone on that rant, I need to find, okay, here we go. For an upcoming landfill reclamation project, a special grading requirement is that no greater than 1 foot of depth for cut will be allowed. Can grading optimization work with the special cut criteria? Does that make sense?
Yeah, to minimize, have a maximum depth of cut. We can minimize the amount of cut, but I don't think we can set a specific value.
No, that would be a bounded point, but it's only a point and not a zone. But basically, with a bounded point, you can put like a lower bound. So you have your EG. You would say you can't go less than what was it, 1 foot? Or
Yeah.
yeah, you would put your bounded point, the lower bound, to 1 foot below your EG, and that would prevent it from going deeper. So I guess in your landfill project, what you would do is you would probably put as many bounded points that you can. It's maybe a little tedious, but I would probably do that. It's not a zone, but you would sprinkle them all over your landfill and put them like 1 foot lower than EG. And it will then keep these points from going deeper down. And if you put enough of them, you should get it's not perfect solution, but it's as close as you can go to that kind of requirement, I would say.
Val, do you think it would make sense to start with minimize earthwork and then maybe put bounded points where it can't minimize to the 1 foot?
Yeah, the minimize earthwork, yeah, you have to try. What it does, it tries to reduce your cut and fills. It tries to stay as close as possible to your EG. But of course, if you have slope constraints, that do not allow that, it will just trade it off. Like this is an objective, it's getting traded off. So
Hey, when you guys did this and we're talking through it, I apologize if you guys covered this, but did you talk about swales between the buildings? Houses?
No, we didn't. I mean, what I think, you would do, and you could certainly do more and more to detail this out. We're just trying to get something that works. But yeah, you'd probably want to put in drain lines here to get the, to create a swale basically. But you could just create some drain lines between each of these. That would kind of force the slopes to go not just from building to building, but swale between them.
Okay. And that does sound like additional work, right? But the more, well, I'm just going to say it, the more you add to this grading object wise. So, I mean, even going down to having swales between the houses so that you can take care of that drainage, and it'll automatically, well, I say automatically, it will include that in the optimization, the better off you are, because it's less grading that you have to go back and do after the fact. Because ultimately, I mean, you have total control of this site. So once you get it to a point where it looks good, it balances, things are working the way you want, you've got your corridor incorporated into it, so you know you're meeting requirements by the municipality or whoever's the governing authority for the roads, you can take it back into Civil 3D and return the feature lines, and you can adjust those feature lines up and down, okay, to more refine the grading plan itself. So it's really just how far you want to take it. I mean, that's just the bottom line. We have internally, Val and I think I've said this on several of these webcasts, Val and I and Charlie have sat down and pushed these things out and thought, well, what about this? What if we add this? What's it, is it gonna help? Or where is the stopping point where you go back and say, okay, now I'm just gonna make a few tweaks and my grading plan's done. I mean, that's going to be up to the user, I think. I kind of chalk it up as close to like visualization, where you're trying to create something that is visually appealing and tells a story. It's really no different here in the grading plan. I mean, the story is it's got to meet the criteria that gives you cost savings, the best cost savings for the grading plan. So in the visualization part, you keep adding things, and man, it just looks better and better and better. But at some point, you have to stop and show off the visualization. It's the same thing here with grading optimization. You can continue to refine the grading in the optimizer by adding more grading objects to do what you need it to do. You'll just come to that point where it's like, okay, now I'm going to tweak these few feature lines here in Civil 3D, and my grading plan's done. So all knowing that, if you're trying to achieve a balanced site, then you have the confidence that it is balanced because you've run it in the optimizer and you can see that it's balanced. So got on a soapbox there, guys. You guys been talking the entire time. I just wanted to throw my 2 cents in, right?
And now we're out of time, John.
Yeah, well, I apologize. Would you
Now
like
we're
to
at
say
the top of
anything
the
else?
hour. No, anything else? Or
we give
No.
John more time next time.
Yeah, nothing like coming in for the meeting and finding out you might be presenting on the next one. So, and thank you guys for that. There has been a lot of great questions, a lot of great interaction between the folks that are asking questions back and forth. They're actually answering some of these questions, right? Or giving information on how they would do it. Guys, that's what we want in these sessions. We want you guys to interact and talk about this. It's great to see that folks are using grading optimization for their projects because we believe it is a definite time saver. Once you start using it, getting used to it, it's just It's just different than traditional grading, but it does save you time for sure. And I think in these last 5 sessions, I think we proved that. So.
Cool. All right. Well, now we're overtime, so thanks
Should
everyone
stop
for
it.
joining. Yeah, so this will be saved to our channel, so feel free to watch it again, share it with other people. And also make sure in 2 weeks, we'll have the last one. We'll see, maybe John presents. I don't know. We'll figure that out.
Great. So you guys have that to look forward to.
Yeah, so thanks everyone for your time. Thanks for joining. Thanks for the team in the background helping out. And we'll talk to you again in a couple weeks. So have a great day. Bye.
Bye-bye.
See you, everyone.